This tutorial is the second part of the block 2, which is part 3 and 4. It deals with digital rights management and watermarking. Of course, we're going to address these two very important topics in a very brief way. However, the floor is open to a lot of readings of articles and especially coverage in the TMA of such topic. So the outline will be as follows. We're going to first present the digital rights management, a brief introduction, then what are the problems, what are the technologies for DRM, and finally some brief presentation of the Impact 21. Then the second part is about digital watermarking, an introduction, how it's done, and the security of watermarks. So by definition, DRM is considered as a set of technologies that control the access and use of digital work. So to have a successful DRM system, it depends on the technology, the IP laws, and the business model of the application. Any problem of any of these three aspects will lead to the failure of the DRM system. The main two functions of DRM are first the accountant and second the policeman. The accountant is about watermarking a certain product, will help tracking the usage of this product to report the information back to some collecting societies to ensure distribution of royalties and the fairness of such distribution. And the second one, when we want to, which is the policeman role, which is to limit the access to the content in order to prevent illegal copying, for instance. So it's important to mention that the DRM will never be entirely effective, but it removes the temptation for the casual copier. And it can be circumvented. This is why we need a legal framework to prevent the unauthorized copying at a commercial scale. So what are the problems with DRM solution? The first one is the people incentives. So people, why would someone buy a digital work that have many restrictions rather than obtaining a free version that don't have or doesn't have any restriction? The second one is the price discrimination. We might have some application with different prices when the DRM is applied. The third one, there is no implementation of fair dealing exception in DRMs, which is the case in copyrighted material, but in DRM it might not be implemented. The collateral damages when trying to remove the licenses, let's say if I have a product with a license, removing the product might have some collateral damages on other products or software installed. And finally, the non-implementation of accessibility features. The main difference between DRM and copyright is simplified as follows. In the copyright law, everything that is not forbidden is permitted, while in DRM, everything that is not permitted, it is forbidden. So in the copyright law, it is mentioned what is not forbidden. You cannot do this, you cannot do that. Whatever else is permitted. While in DRM, it is mentioned what you can do, but whatever else will be forbidden, and the restriction is totally different between these two approaches. And of course, the DRM is more restrictive compared to copyright law. And the DRM is strengthened by the recent law changes. So let's consider the US Digital Millennium Copyright Act and the EU Copyright Directive that make it illegal to bypass DRM technology. So bypass such technology is like breaking the law. So this highlights two obstacles for DRM technologies, which are first, bypassing these technologies, and second, the non-satisfaction of the customer and consumer regarding such technology because of the restriction. If I have a technology that is broken someplace, and this break of this technology will lead to breaking this technology everywhere else. This is what we call Bob weak, standing for break once, break everywhere. And if breaking this technology will in one place will not lead to breaking it elsewhere, this is what we call Bob strong. Let's consider an example. If you have a product with a key, license key, and this license key can be applied to n products. So if someone knows the key, it can use it to install the same software on different PCs using the same key. And this was the case of old version, let's say for Microsoft Windows. While if you have a kind of validation server that has to check every copy of the software before allowing it to run, this will make the DRM system stronger and can be considered as Bob Strong. So the components of DRM are three. First, the license evaluation, which can be software or hardware within the system to evaluate the license against a requested action to say that it is allowed or blocked. The authentication component to identify the licensee, that can be a human or a piece of software or hardware, and of course a way to associate licenses to bind the license with the content. We have two types of content: a managed content where the content is associated with a license using some technological means, and unmanaged content where the content does not have a license. If we somehow are capable of converting a managed piece of content into unmanaged content, so we can say that we broke the DRM. So this content that is illegitimately transformed is called dissociated content, which means an managed content convert to unmanaged. Two examples of DRM techniques: the secure container methods that we have seen previously, for instance in the WMA. So we have the content encrypted and protected using the key that can be obtained through the license. The problem is, if we are capable of converting the managed content to dissociated content, this is what we call the analog goal. For instance, if you have a WMV file that is protected, and then you have the license, and then you can do a kind of screen recording, so you get the content but in an unmanaged form or dissociated form. The fuzzy hashing is some techniques that attempts to compute an identical hash for two pieces of the content if they are perceptually equivalent. If we have a managed content and unmanaged content or dissociated content, both they have different size maybe or different information, however they are perceptually seen similarly. So these two will have a fuzzy hashing, and you can refer to the book for more example about fuzzy hashing. We have two categories of DRM, the ordinary and draconian. In the ordinary DRM, the devices handle both managed and unmanaged content, while in the draconian DRM, devices that handle unmanaged content cannot handle managed content, or vice versa. We have two an important standard that deals with digital rights management, which is the MPEG 21, known as REL for Rights Expression Language. It's an XML based. It explained how a license can be written in a structured way to allow interoperability of different hardware or software dealing with DRM. The example here shows one MPEG 21 XML file where we can see the license with the key holder and the signature of the license, and then the key used for the digital signature. This is the principal. Then the right, let's say in our case, this is the resource. And the condition, you cannot use the license before a certain date and not after a certain date. And then the issuer of the license. This is an example of an MPEG 21 right expression language file where we can see the different component. This is the issuer of the license with the key used, and the license itself where the principal, the name of the holder and its key, the resource that is protected, the right which is to play the file, and the condition, let's say not before or not after. Now let's move to the digital watermarking part. So digital watermarking refers to technique for embedding marks in digital work. So it does not make the encryption more secure, but it offers additional protection of tying the copyright information to the content in a secure way. It may even be possible for the watermark to survive digital to analog conversion. So if I have a work that is watermarked, it is managed. When I move it to a dissociated content, the watermark might survive this conversion. So it has different applications other than copyright protection. And it is very important to mention that watermarking is not steganography, and we're going to explain why. Steganography, and you have seen this concept before, attempts to hide the existence of the message, and it is independent of the cover work. So a military writing a letter will not put the letter inside a picture of a tank. It will put, let's say, this letter inside a picture showing the sun and the sea, etc. So the content is, the cover work is independent from the content itself, while in the watermark it's not the case always. The information contained in the watermark is generally related to the work in which it is embedded in general. The presence of a watermark is generally known, which is not the case in the steganography, and these are the two main differences. So I will summarize. First, there is no relation between the covered work and the content in the steganography, while it is the case in watermark. The presence of the watermark is generally known, while the steganography attempt to hide the existence of the message. So we have three types of algorithm for watermark. First, the insertion. Insertion algorithm takes the user key, the input image, and the watermark and gives a watermarked image. The extraction, you will have the watermarked image and the user key used using the insertion to get the watermark extracted. And the detection of the watermark, in some cases you will need the user key, the watermarked image, and a specified ID regarding to the watermark to say that this work has been watermarked or not. There is a number of requirements for a digital watermarking algorithm. The first one is the imperceptibility of the watermarking process. So the listener or viewer should not be able to hear or see whether the cover signal has been watermarked. A high capacity. So the capacity should be high for the intended application. So let's say an application that needs to embed, let's say, a watermark of 1 megabyte inside 1 gigabyte. So the watermarking algorithm should provide such high capacity. And the higher the capacity is, of course, while respecting other requirements, the better the watermark algorithm is. Reliability regarding the false negative and bit error rates should be low. Robustness, tamper resistance, the security should rely on the secret key, as we said, regarding the Kirchhoff principle, and the cost constraint of the application regarding performance and processing. The payload also should be spread over the digital work, and the further it is spread, the better is the watermarking. There are three categories of attacks against the watermark. First, unauthorized embedding of watermark in order to create, let's say, the fake authenticity. So we might insert a fake watermark after modifying the work, and the user might think that this is the original work while it has been changed. The second one is unauthorized detection or extraction, especially if there is some confidentiality of the information. Let's say if I have a medical report and the name of the patient is inside, like a watermark inside the document. So an attacker should not be capable of detecting the existence of the watermark and extracting this information. And finally, the unauthorized removal attacks. This is the third category of attacks. We have two types of removal, unauthorized removal. First, masking, and the second, elimination. Masking modify the watermark in an attempt to fool a detector that the watermark is not embedded. So the watermark is still there, but the detector cannot detect it. And removal will remove it completely.